All right, Algebra 1 skills number 27, linear models in context. So we're going to look at linear models as they arise in word problem situations. First, some notes here. The y-intercept for a linear model in a word problem situation represents the starting amount. Where do you start before action took place on that? Slope would be your rate of change. So how much is that starting something? How much does it change by per unit of time? Domain. Now we're going to talk about domain both graphically and in context. In context, it's the collection of all your x values or all your independent values. Explain more when we get to an example. And range, which you hear synonymous with domain, they can always come together. Again, we'll discuss graphically, but here it means all your y or dependent values. So let's look at some situations. So we have a repairman that charges $50 just for showing up on a job and takes $25 per hour for what labor he has to do. He works at most 8 hours on a job. Okay, so this model represents the amount of money made by this person, $50 and then $25 per hour. So the y-intercept is the $50 or the initial amount. He might show up and maybe he's working on a refrigerator. He shows up and says, the reason it doesn't work is you didn't plug it in. Doesn't have to work at all, but he gets $50. That's the initial amount. But that $50 is going to go up for what he has to work. So if he actually has to start working on the, replacing a part, getting inside the refrigerator, whatever, that labor is going to cost the $25 per. So y-intercept is what it was at first, and the slope represents how much it's going up by. So here's a graph of the situation. Here's the hours on the bottom. Notice we don't go left of 0. You can't work negative hours. Also, he does not work beyond 8. And this represents money made. Okay, so the domain, again, is all your x values from 0 to 8. The range is all your y values from 50 to 250. And notice that the y values generally depend on the x values. So here the money made depends on the amount of hours worked. It wouldn't make as much sense to say it the other way around. Generally, time is independent. Now, there is no x-intercept here because we can't extend to the negatives. So it has no relevance for this example. A person has a goal to lose 72 pounds and loses 8 pounds a month. Okay, so here we have, again, a y equals mx plus b. It's a little bit in disguise because it's backwards, but that's your b, and that this negative 8 is your m. Okay, so it's just written, it could be written negative 8x plus 72. All right, so your y-intercept, again, is the initial amount of pounds to lose. Now, this person doesn't weigh 72 pounds. That's just how much they want to lose. This is charting the amount of weight lost, okay? The slope is negative 8. That's how much the goal is going down per month. Again, you start with something and it changes over time. Here's that graphed. Okay, so the amount of pounds yet to lose as months go by. Your domain, again, is your time or your x here, 0, and you can see it goes to 9 there if you look carefully. Your range is the 72 pounds to lose all the way down to goal being met, 0 pounds to lose. Now here we do have an x-intercept of 9. Remember, the x-intercept is when y is 0, and since y represents pounds to lose here, the x-intercept, the relevance of that is it's the months until you have 0 pounds to lose. Okay, so that is relevant in this situation. Okay, a third example. The following table shows the score of a student. A student will score on a 5-question quiz. Okay, so the mistakes made and the score. Okay, so for this particular one, again, our f of x is 100 minus 20x. Now this one's a little tricky. We're not going to graph it. Instead, we're going to talk about, well, first, the y-intercept 100 is the score with 0 mistakes. That's where your your grade always starts with a 100. You can think of it that way, and then anytime you make a mistake, it goes down from there. And then negative 20 is the amount of points you lose per mistake. Okay. Now your domain, notice this time it's not like the others. The others we said between 0. We said 0 is less than or equal to x, which is less than or equal to 5. But here you can't make a half a mistake. Okay, that doesn't make sense. So we have a discrete. This is more like an arithmetic sequence here, where you can only use discrete values. You can't go in between them. So your domain, every possible independent variable here is 0, 1, 2, 3, 4, 5. You can't get in between. And similarly, you can't get in between these scores. Okay, so we only list those for your range. You can't possibly score 30 here, for example. And note that your score depends on the number of mistakes. That's why these are your domain and these are your range. Time is not involved on this example.